So here we have a parallelogram, and then we've got a new point way off in the direction. And we're given ratios. And all the ratios mean, so here we have our first ratio, AB to BP, means that whatever length AB is, say it's 2 because that's the ratio that they use, then B to P will be 1. And that whole length from A to P would be 3. Now, we don't know if it's 2 and 1. It could be 4 and 2. That would still be the same ratio. All we know is AB is double what BP is. And same thing, if CQ is 1, then QB is 3. QB is 3 times the length of CQ. Okay? And now I'll bring this back to a question as if you would do it in grade 10 geometry. If you had this, and this was a parallelogram where this was 4 and this length was 2, okay? With that angle there, how long is it from O to P? No, because probably in grade 10 they'd say, oh, that would be too much work. Okay? We're going to look at how we would set this up with vectors. So, well, we'll do some stuff. We'll do some stuff now with vectors, and then show you how you could then use those vectors to actually solve this question and be fairly straightforward. And then you can take this same thing and you say, if we had a similar question in 3 dimensions, because we did some 3-dimensional vectors, then you could figure out similar distances quite easily. Okay? But starting off, we're going to express each of these vectors in terms of A and B. A to B. So how would I get from A to B? Suggestions? Negative A, and then plus B. Now, from A to P, how many times AB is A to P? Well, if it's half, I would only get to here. 3 halves? Does that make sense? That if half is here, this would be 2 halves, which is just A to B. And another half would be 3 halves of the way. So if I wanted to go from A to P, that's 1.5 times A to B, based on the ratios that I was given. So this will be negative 3 halves A plus 3 halves B. And now that we've done the preliminary work for A to B and A to P, if you wanted to start at O and get to P, could you see that you could go from O to A and then A to P? So I'll write that out. You could go from O to A and then A to P. And since we figured this out already, O to A is just A minus 3/2 A plus 3/2 B, giving us negative 1/2 A plus 3/2 B. I'm going to get you to try OQ on your own. How did we go from O to Q? Suggestions? Just tell me how to get there. Well, that would be the answer. Yes, but you went from O to B? And then, so we went O to B, and then minus 3/4 of, well, if you went minus from B to C, actually, I'd say plus 3/4 of B to C. Does that make sense? Okay? Because we're going from B to C. So you went from O to B, and then 3/4 away from B to C. So O to B is B. That's straightforward. And now we have to write, how do we write to go from B to C? Negative A. Because it's a parallelogram, C to B is the same as the vector A, which was on the bottom. And so this becomes B minus 3/4 A. Now part B, we want to show that if you went from Q to P, that it would be the same as going 1/4 A plus 1/2 B. All right. So for any point on a coordinate graph, you can find its position vector, and it becomes very powerful because once you have a position vector, you can find any other vector from any point to any point by just using the position vectors. We can go from Q back to the origin, and then go from the origin to P. And QO will just be negative of what we found before, which was B minus 3/4 A. And O to P, what was it from before? Three half. Well, 3 over A. Sorry. 3 over 2 what? B? Minus A? 1/2 A. So OP was 3 over 2B minus 1/2 A. And then putting this all together, we get negative 3/4 minus 1/2 will be negative 5 over 4A. And then we'll have, oh, just a second, got to distribute that negative, right? We get positive 3/4 minus 1/2 will be positive 1/4 A. And then negative B plus 3/2 B will be plus 1/2 B. Yes? You got the same answer? Yeah, there's different ways that you can get. Any way that you can use vectors that you have to get from Q to P will work. Generally, though, we do like to use position vectors as much as possible because it just makes things simpler. Once you get a position vector, you sort of use your origin as your hub, and you can always go to the origin and then go somewhere else. It's like flying to Winnipeg from Saskatoon with WestJet. Where do you go first? Calgary. And then you go from Calgary here. Because Calgary is kind of like the origin, because all of WestJet's flights, their main hub is Calgary. So if you want to go anywhere, you can go to Calgary first and then get your direct flight. Yep. Exactly. You fly over Saskatoon and say, that's where I'm going to go. I'll be there in about 4 hours. And then later, you get to that. Oh, and that's